Hello and welcome to Food Safety Fridays. My name is Simon Timpley from the International Food Safety and Quality Network. This is the second one. We've already just done one with Karen Constable, food fraud, and now we're going to be talking about food defense in the digital age, cybersecurity and physical protection integration with Amanda Evans-Lara, Director of HACCP Mentor. It's very late for you. You're another Aussie. Karen's from Sydney.
Sydney, yep.
So it's like midnight.
Yes, it's just gone midnight on a Friday night.
So everybody in the chat, midnight on a Friday night. Amanda's here talking about food safety with you guys. So say hello in the
Dedicated. I'm dedicated.
100%. Tell us where you're joining from in the cyber. Ho Li Chi from Vietnam. Todd from Michigan. Oh, where else? Let's pick somewhere that's... Oh, Melinda from Jamaica. Sorry, I can't read your name out. Collins from Guyana. And Elisabetta, I read your name out in the first one, so you're dedicated as well, from Italy. Right, I'm going to read... I'm not going to read, I'm going to play the sponsors ads, and then we're back for Amanda's presentation. Okay. Right, I'll be back for the Q&A later. For now, I'll hand you over to Amanda. I'll just make your picture a bit bigger there, if that's okay. And
yeah, I was going to say, do you want me to leave it on or turn it off?
Yeah, if you want to. It's up to you.
Oh, okay. See how it goes. Like I said, it's late. People might not want to see me looking tired.
It's not mandatory. You can switch off if you want.
Okay, thank you. Just because I think there'll be things in the bottom of that slide anyway. Okay, so today we're going to be talking about cybersecurity and physical protection integration. We've got this whole piece around food defence in this digital age. And now we're seeing really this overlap between cybersecurity and physical protection for modern food businesses that are or operations that are happening now. So when I say digital age, I mean things like plants that rely on automation, connected equipment, remote access from vendors. It could be cloud dashboards, integrated data systems, things like that. So like these type of capabilities do bring huge benefits, but they also unfortunately create these new pathways for intentional harm if they're not managed as part of your overall food defence program. So I've really designed this session on a mixed audience because it's very much a shared ownership, this piece now. Food defence coordinators, IT, security, this is all within your business. You've got your ops managers, your compliance officers, QA, because again, in this context, food defence is now like a cyber physical risk management, and you need a cross-representative team from the business to actually take ownership of that. Excuse me, let me turn that camera off there. So the key things that I want to touch on today, like I always like to do learning outcomes, so you know what we're going to cover. So this session, we want to firstly align on what cyber physical conveyance means for food defence, and then we're going to have a walk through some common attack paths, so how weakness in one area can basically cascade into a product impact. Then I want to give you a minimum viable integrated risk assessment approach that you can run within your own business without turning it into like a year-long project. And then finally, we're going to have a look at some layered controls and an integrated incident response mindset. And this will include like doing like a little mock scenario that you can basically replicate within your own business. Okay. So as Simon said before, my name's Amanda Evans-Lara, and I think this is maybe my 10th or 11th session of doing these for the International Food Safety Quality Network. I've over 30 years experience, auditor, trainer, based behind HACCP Mentor. Consultancy, probably my biggest change from last time when I did this was I'm now just working with BRCGS in Australia and New Zealand region as their commercial representative a couple of days a week. So that's been it's proving to be a great experience doing that. So yeah, shout out to me on LinkedIn. I'm going to stay up to date as well. Okay, so before we jump into things, I want to get really clear on just the language and the terms. Because we've got different teams that are required for this now, not just your QA team. So food safety is about unintentional hazards, so things like your microgrowth, allergens, your sanitation failures. Food defence is about your intentional harm. So this is what you would traditionally be doing in your food safety management systems if they're GFSI. So this is your malicious contamination, your deliberate tampering, intentional disruption that affects like your product integrity. And then we've got this other piece now, which is your cybersecurity, which is typically framed as protecting systems and data. But now that we've got more and more plants that are becoming IT heavy, that it also now needs to cover protecting your product integrity. This is because systems control things like mixing, dosing, alarms, records, traceability, maintenance, things like that. So throughout this webinar, my whole piece is to see that some cybersecurity controls are actually also food defence controls. And because they prevent unauthorised access or changes, we want to look at that and how that would end up impacting the product. So many facilities, and this is basically what's really changed over the last, say, 5 years, are now using connected OT, ISC, ICS systems, IoT sensors, cloud reporting. There's an integration between your operations and your business systems. We've got vendors may connect remotely and troubleshoot into your equipment. You may have operators in your business using tablets or mobile devices on the floor. So we've got data moving around the factories like faster and further than what we ever had before. So there's been this risk shift that now we've got a lot more what we call soft targets. So think about your accounts, credentials. We've got remote access pathways. We've got these integrations and all of these connected devices that we probably didn't really have that in place before. So importantly, the physical and the digital risks can enable each other. So if we have a physical intrusion into a site, that can lead to a digital compromise. And a digital compromise can actually trigger physical consequences, like having altered set points in your machines or disabled alarms. So these OT systems and IoT sensors are both part of the digital side of modern food manufacturing. And for those who may not know what these systems are, I'll just give you a few examples of these different types. So you've got OT systems, which is basically operational technology. So these OT is basically the technology that makes the plant run. So it refers to the hardware plus the software that directly runs and controls your physical processes in the plant, things that turn motors on and off, control temperatures, open valves, run conveyors, dose ingredients. Think about those type of things that may be happening in your factory. So you may have like PLCs, which are programmable logic controllers. So they control pumps and mixers and conveyors. You've got HMI screens, so any kind of operator control panel that you may now just be doing touch panels. Distributed control systems in larger continuous operations. We've got industrial networks, which basically connect all your production equipment. We've got systems that control your CIP or your pasteurizers or your fillers or your packing lines, things like that. So that's what those operational technologies are. So when we look at the IoT sensors, which is the Industrial Internet of Things, so these are sensors that are connected measurement devices that report on what's happening in the plant. They're generally connected to networks that collect and share data. Often this is happening in real time, to local systems or sometimes straight to the cloud. So some examples of these could be temperature, pressure, flow, level sensors. Even think about your cool room temperatures going back to a central monitoring system now. You might have vibration sensors on motors or bearings, which come into predictive maintenance. So as machinery vibrates, it might say, okay, well, it's done certain vibration patterns, so we now have to do maintenance on that piece of equipment. We've got environmental sensors, so our humidity, air quality, track and trace sensors. So if you're trying to find a certain asset or its location within your factory, when doors are open or closed. I think probably everybody, if you've got your roller doors going from your dock outside, they're on sensors. And then we've got smart meters as well, could come into play if you're doing a lot of the environmental management capabilities around your water and your energy. So because these OT and IoT can change or report process conditions, they are the things that become a pathway for intentional harm if your access, permissions and monitoring aren't well controlled. So this may be something that, well, what I've seen as an auditor is not being picked up in your food defence plans. And I think a lot of that's just because of you're in quality and you just see IT as maybe, your word processing or your emails and all that type of stuff. But to actually understand the impact on what you're actually doing day to day, that's what we kind of want to focus on in this presentation. So to try and keep this practical, I've come up with this simple model, which has basically got the 5 layers. So think about this as like real incidences will often cross layers. So that's why we need to make sure that whatever controls we put in place must also go across these layers. So if we start with first the supply chain. So inbound materials, your transport coming in, your service providers, third parties. Then we have the human layer. We've got the training of these people. We've got insider risks, which we would traditionally know as the inside attackers. Contractors, we need role clarity. There's fatigue within the human resource. We've got the culture of the business comes into play. Then we look at the digital piece, which is your IT systems and your OT systems. So networks, controllers, sensors, remote access, logs, especially if you're now even having to log on, fingerprint logging in to, which generally hooks up to your HR systems to say whether you've worked that day and how long you've worked. All of that stuff is connected when we're talking IT systems, be your OT systems. Your process, so how your product's actually handled. So think about mixing, dosing, rework, changeovers, your CIP and things like that. And then we've got our physical layer, which is what I would expect anyone who's doing GFSI standard. So this is your base physical security, like your perimeter, your doors being shut, your access control, how you manage your visitors, your storage, and how you manage your utility inputs as well coming into your business. So when we want to think about like where could this harm occur within our business, we know that food defence becomes manageable when you actually, in this context with cyber, we focus on our high leverage points. So places where a small action can create a large impact. So in many operations, those points are going to include things like bulk liquid tanks, mixing vessels, dosing systems, water and ice systems. If you've got rework handling, chemical storage, packing steps or packaging steps. So if you're joined today from the US, you'd be familiar with these, with the FSMA requirements around intentional adulteration, where they do talk about these high leverage points of the bulk liquid tanks and the mixing vessels and dosing and things like that. So for this, you can use a structured vulnerability thinking. So again, TACIP or the Carver style approach. Carver is what the US base their FSMA requirements on, to basically go in, identify and prioritise your vulnerabilities. So you don't need to be perfect with this, but you do need to be focused. So your operation teams usually know where these points are instinctively, but the win really is in documenting them and linking them to controls and monitoring. So who are we actually planning for? So we talk about these threat actors. So some of our common profiles, and you may not have included the last one of the last ones from a cyber perspective. So we've got our disgruntled employees, could be coerced employees or compromised credentials. Then we've got our criminal actors, and they're all about the extortion attempts, and we've heard plenty of cases of extortion of businesses in that space. We've got our activists. Again, this is another space we've had experience in, where their main aim is to disrupt the business or cause reputational damage. We also have opportunistic intruders, where they could be walking past something and see something that's open, see a stock door open and just basically go in and want to cause a bit of havoc. So they're basically exploiting the gaps. And increasingly though, and this is the one you may not have considered, is we see these vendor or third-party compromise, where we actually give people legitimate access to our systems, and they're the things that get misused or they get hacked. So the takeaway from here, it's not fear, it's just this is what's real. So you should always assume that access can be misused, and therefore you need to make sure you've got your controls are designed to consider these things. So let's look at a simple scenario here, where we've got physical to digital to product. So think about like a tailgating incident where someone follows a worker into a restricted area. Okay, this can then lead to access to a workstation or a control room. and all they have to do is just put in a US device or an unauthorized login to get a foothold into the OT systems. And it's from there that once that USB goes in, that it can be hacked into, and then changes can be made to your settings, to your alarms, or to your records. That's really how easy this can happen. So this is where we talk about those basic physical controls around, your badging, your escorting visitors, your restricted zones. Like, they are so essential to have in place. But it's also what those, it's also why those IT and OT controls also matter, because we want to be able to segment those systems. We want to be able to lock them down quickly on endpoints. We want to have role-based access that can basically stop the chain. So if in your business, you have a panel that you access and everybody uses the same password, they're the type of things we're talking about here that really need to be tightened up. So let's now have a look at the reverse of that. So if we go digital to physical to the product. So if a remote account is compromised, say like a vendor login, and I'll just use maybe a cool room or a CIP system or something like that, pasteurizer. So the vendor who actually manages the equipment has login, so they can do remote help. So, it's a bit like if you've got and I actually had this happen to me the other day. I needed something fixed on my computer for BRC, and I had like a remote person come in and they were controlling my computer, and it was still freaking me out watching someone spinning my mouse around and opening things and things like that. So that's what I'm talking about in the simplest form around what a vendor login would look like. So in this situation, an attacker could adjust the dosing set points or recipe parameters. They could go in and manipulate your sensor readings, so the process actually looks normal, but when you look at it and it looks normal, but it's actually not normal. They might go in and disable alarms or reduce monitoring visibility, like your CCTVs. You think the CCTV is on, but it's not on. And audit logging is another thing. So the key point here is that data integrity is product integrity. Okay, data integrity is product integrity. So any of these silent changes can be more dangerous than the obvious outages, because these are the things that can persist undetected within your system. Okay, so let's have a look at this integrated risk assessment. I said I've kept this pretty simple, okay? So it's a practical method that you can run in a site without actually creating a massive giant program. So your first step is to define your scope. So what site are you talking about? What lines you have, what utilities, what your warehouses, what labs. The second piece or second step is to go through and list out your critical points and the enabling systems. So yes, we're used to doing our codex and our food safety flow diagrams, but actually know what happens with the equipment at those steps. So are they connected into something? Okay, so what are their enabling systems? What's their software? Who are the people that have access and control those particular things? Step 3, go through and define your threat scenarios. So think about these cyber threats. Think about your physical threats, which I suspect you would have done that anyway out of your basic food defence program. And then they're going to be combined. Step 4, what have we got there? We've got likelihood and impact. So like your HACCP, rate your likelihood and your impact using whatever risk assessment criteria that you have in your business. Step 5 is to go through and then select your layered controls and the monitoring that goes with those controls. And very important for step 6 is to make sure that you've assigned owners across food defence, IT, operations, and your compliance. Okay, so we really want to deliver an integrated risk register. So one version of truth for the whole organisation or your whole business. So you're not running separate, disconnected risk conversations. So IT are talking to quality, are talking to maintenance. So everybody is on the same page. And that's really important to do that. And if you're not doing that now, that's obviously going to be a takeaway. Okay, so let's have a look at some of these controls that we can go through. So again, use this a layered defence. The first bit is to deter, so make threats less likely. So you want to have visibility, good culture within the business, clear rules. Our next layer would be to try and deny. So we want to prevent access. So this is where your physical thing is going to come in, like your locks, your access control, your segmentation. Then we want to have detection. So how do you notice abnormal events? So what are you monitoring? What alarms have you got in place? What type of logging is being done in the back end of any software that's attached to any piece of equipment? We want to do a delay if possible. So this is all about slowing down the harmful action. So if we can put barriers in place, have approvals, have like dual controls or dual approvals. Maybe there's multi-factor that's got to be employed. Maybe you need a secondary person to come in and put their code in before anything can be overridden, recipes can be overridden or things like that. And then our final layer is, if everything gets through that defence, we've got to have a response and a recover. And this should really be contained in your contingency planning now. Again, if you're GFSI, you get audited against that. So it's around how you contain the problem, how you do your investigation, what product's being affected, how you dispose of it, and how you get back to a recovery state for your business. Now, if you just go through and rely on only one layer, you're basically betting everything on that one solo control working perfectly. And we know that that doesn't always happen. Otherwise, we wouldn't have food recalls, right? So it's this whole layering is what creates resilience within the business for this part. We talked about these physical controls as well, and you might see that you've probably got these in play, but obviously we want to test how good they are, and you should be again doing that as part of your basic food defence program. But these physical protection controls really should align to those critical points that you've identified, and they're not just a blanket rule everywhere. So these strong controls are often what we see as being these restricted zones for high risk ingredients or dosing areas, or those bulk liquid storage vessels, visitor and contract management, key control, escorting practices, your camera coverage for your CCTV that actually support your investigation. So your CCTV stuff, they've got to be directional. It's no good having this nice big broad coverage of your CCTV, but you can't actually see those high risk areas and zoomed in really well. So we need to make sure restricted is real. So having clear boundaries, that controlled access and enforcement of that. And then we need to make sure that we design monitoring so that you can answer basically who was where, when, and why, especially in those high leverage areas that you go through and identify. On the cyber side, the big wins in this for controls is looking at those IT, OT segmentation. So separate your business systems from your process control zones, because we want to reduce what we call blast radius. So I'm sure everyone's heard about, don't click on links in emails, don't, there could be phishing attacks, which then go in and put viruses on your computer. So if you've got your IT system on the same system as your operation stuff, like, you're just opening yourself up for heartache there. So this is what we're talking about. We want to segregate those so we can reduce those issues from happening. Secondly, we want to have some remote access governance. So this is where you're going to do your multi-factor authentication, your approvals, maybe time-bound access and vendor controls. So maybe it is that, people external to your business who come in and do stuff with your equipment, the people who run the equipment or maintain it, they've got to have approval. So you're doing your tracking. And it's only to a certain amount it only happens during a certain amount of time. Thirdly, you need to have a control around like your OT and your IoT asset inventory and what your backup strategy is, because you can't protect what you can't see and you can't recover without backups. Okay, so that's really important for that piece. Our next one is logging and alerting for high impact changes. So having these built into your system, like someone should be getting alert whenever a recipe is edited on a machine or a set point is changed. And we're talking like a temperature set point or a chemical set point. If there's any alarm suppressions, if admin logins have been accessed. And then finally, we've got the piece around privileged access management. So this is basically restricting who can do what and making those actions traceable. So we should be able to see when people log in, what they actually looked at, what they actually changed. This is what we're talking about, having these traceable management with that. So really, this is where IT security and operations need a shared model, because IT, they want to have uptime. So you want to protect the uptime, where your QA are probably more concerned about protecting the product integrity and having at least trust in the records that are being produced. So we need those two areas to actually come together and not be segregated on this. Some process controls that reduce your intentional risk. We've got operational process controls. They're basically your major defense layer because they reduce both malicious and accidental pathways. So your key controls include like your formal recipe and batch change control. Again, having procedures written on all of this stuff and implemented effectively. Dual verification of high-risk additions. So that's what I was saying before about you have a secondary person have to put in their own login and approve. It's that review approve process. Strong rework governance. So how you actually do that process. Clear exception handling. But also especially who can override controls and how that stuff gets recorded. Even just a simple thing, just down to your metal detector going into that lockbox from a reject. If everybody has access to the key because the key's just sitting on top of the metal detector, it just makes it irrelevant, really. Anyone can get in and put rejected product back onto the line. A helpful principle is digital approval plus physical confirmation. So approvals for the recipe changes combined with verification at endpoint addition. That's going to be an effective process that you can put into place. Now we've got compliance. This compliance piece is often where your programs are going to succeed or they're going to fail, because basically if it's not documented and if it hasn't been trained out, if it's not reviewed and it's not verified, it's not going to hold up to scrutiny. So the expectation is that you as a business, you have your documented food defence plan, you have a clear vulnerability assessment method and a review process for that. There's effective training and awareness around food defence and the cyber defence. The verifications that controls are actually operating. And then you have your incident readiness and defensible evidence trails, which, you should have that as part of your crisis management. A modern addition is that logs, so we're talking access control logs, remote session logs, OT change logs, all of that stuff becomes part of the evidence your evidence, if all this process is managed properly. So it's getting all of that stuff off, the data off the machines. I always thought it was, just from a food safety perspective, interesting of when automated cool room monitoring came in, as opposed to, physically walking around and recording temperatures and looking at temperatures 3 times a day. Now we have these automated systems. Nobody bothers to look at the temperature. And I actually had a client recently who their cool rooms were actually down for 2 days before they even knew they had an issue. 2 days. The alarm system didn't work, so nobody even knew. So they had to throw out all their cold rooms stuff. I know that's not a food defence issue. It was just a straight equipment failure. But yeah, the alarm didn't work. So these are the type of things that can happen, but intentionally happen by bad actors. From our monitoring perspective and verification, think about monitoring answering the question of, are the controls actually working day to day? That's what monitoring is about. Some examples of practical monitoring can include looking at unusual access events, off-hour remote sessions, unapproved recipe edits, your alarm suppressions, or frequent overrides. So you're going to have to look at data with this stuff, right? Any abnormal behaviour in your sensor trends, for whatever it is, environmental sensors you've got into play, your CCTV uptime in critical areas. And I always say, try and put some simple KPIs around this stuff as well. You want them to be simple. You want them to be meaningful. You're not trying to create like a wall of metrics. You're just trying to spot a few signals that could indicate an increased risk for your business. So I've just put on the screen there, there's some simple KPIs that you should be measuring, those type of just really simple things. Your incident response, and this is where integration becomes essential. So a good structure is basically detect, triage, contain, investigate, correct, recover, which is basically what we see in any type of crisis management or incident response procedures. A lot of the times the hard part is the decision making on a product, like when do we hold the product, when do we stop the line, because you've got all of these production pressures. You've got to get the product out in the marketplace, and if you've had a breakdown, then you're running behind time, and then you might start rushing a few things, and things start slipping through the cracks. So it's basically, you've got to have these decision-making processes down pat. So when you stop the line, when do you actually go and notify your customers or regulators when you've actually identified an issue? Again, a lot of this should play into what you've already got for your food recall systems and your contingency planning as well. So it might be worth going back and just having a review of that and seeing if you've also considered the context of what we've been speaking about today around the cyber stuff. Your Evidence sources must be planned. So again, having a good knowledge around what those logs are that come out of those pieces of equipment, yeah, that's going to be really valuable as well. Now we can do, like all our little mock traceability. We do mock traceability, we do mock recalls, we do, crisis event mocks and all of that to see how your systems are working. And we can do exactly the same thing with this. So if we wanted to just think about a scenario of, and you can again do this for your business as part of your mock area. A vendor account gets used at 2 a.m. You have a dosing set point gets changed. The sensor readings actually look normal, and the camera near the ingredient area is offline. Now, in that first period of time, after all this is happening, there's certain things that should be triggered like really quickly. So you want to be asking yourself these questions when you do this activity. From a food defence, like what triggers a hold, who gets called in, what facts have to be confirmed. Then if we want to look from an IT security, because you're going to actually have to bring in another group of people for this, is how do we contain the account? How do we validate that remote session? How do we preserve the evidence? So think about those logs I was talking about before. From an ops perspective, do we stop the line? What physical checks do we need to perform? How do we actually segregate those affected lots? Again, we should have procedures around that already anyway. And then when we want to look at the compliance piece, like how do we actually document those decisions and evaluate those notification thresholds? So really the point of doing a mock exercise for this perspective, it's not perfection. It's about just that being able to coordinate all of those different areas for defence, from ops to compliance to the IT people to the food defence team. We want to be able to coordinate them, and they need to be making clear decisions when they're under pressure, because you've got to move really quick on this stuff. Okay, so here's your roadmap for the next 30, 60, 90 days. First, we want to look at building visibility. So I want you to go back and look at your asset and your access inventory. So who's got access to what machines, to what equipment? I want you to map your critical points in your business. I want you to review what vendors have remote access to these pieces of equipment and anything coming into your business. And go back and have a look at your visitor controls and just review that they're still relevant. Then around about 60 days, give you 2 months in, start hardening up those key pathways. So look at how you can segment. Again, if you've got your IT system on your OT systems, we want to look at segmenting that off the same platform. Look at your baseline logging and your alert systems. See if you've got dual controls in place at your high risk steps. So that's do I need 2 people to sign off this before we can make a change? If someone was to I don't know, even just with your metal detector, is it just one person can change the sensitivity, or have you got a backup person who needs to confirm it? And then going out to 90 days, this is where you can start operationalising the whole thing. So finalise that integrated risk register, run your mock activity, assemble an audit-ready evidence pack so you know what you're going to have in place, so you're not scrambling for that if it was to happen in real time. And go and set those KPIs for your review process. But just remember that the whole thing is around this shared ownership. It's not just on QA, okay? So each action needs to have a named owner who's across the functions so that nothing like slips between the cracks for these different departments. So to wrap it up, the key things that we've kind of messages I want you to take away from what I've discussed today, that food defence is really cyber physical and the pathways are connected. It's not just about the physical anymore. Integration prevents blind spots, so no one function sees the whole picture alone. So we need to be talking to other departments within our business. Shared ownership matters. Again, your food defence teams, your IT, your ops, your compliance, all hold pieces to the solution. Want you to start practical. I said, look at those critical points, identify them, identify access pathways to those points, get in place your monitoring and your response readiness. And then really, I think the whole piece is that we're looking to protect the product by protecting the pathways, both physical and digital. So that's where I'm going to, I think, wrap it up. I've probably gone, not too bad, I suppose, Simon. I've done a bit in the...
No.
Probably longer than what I normally do. I'm trying to normally about a half hour, but yeah, I kind of really get into this stuff. So
no, it's great.
And I just think it's something that people, they're not considering the cyber. They're only just considering it in their IT systems, not in their OT systems.
Definitely. Very important. And I'm just wondering if we've got any questions. Can you see any? I can't see a single question in the Q&A.
Oh, well, good. I'll go to bed then.
Can you see any in the Q&A tab? The cyber.
Let me see. Jim put a link into something. So
yeah, there is.
That's good. Thanks, Jim.
Yeah.
And
there we go. The two screens is the chat and then there's the Q&A. But Collins has put something in now in the questions. So what is the sharp difference between cyber threat on food industries and food defence in simple terms?
Well, it's not really. Sorry. Food defence traditionally has only just considered the physical aspects. Where now what I'm saying is you need to consider the cyber and the IT systems and the OT systems. Okay. So the operational technology that's associated with your equipment. And even if you're recording, you're doing digital record keeping on the production floor, even those tablets and mobile devices or whatever you're using, how do they fit into it? How are they protected? They're the type of things we've got to look at. Okay. Big long one from Hakan. Assuming that the physical security wall and the cybersecurity wall could collapse together in the same disaster and without mapping the dependencies between physical and cybersecurity, how can we objectively determine which single control simultaneously reduces the highest risk in both domains? Oh my goodness, that's where risk assessment comes in. This is what I was saying. Go through and just firstly identify and then look at, okay, if it's a segregated system, like on the floor, and you're not going to know that until you get into the system and see how it operates. Is it in let's say a cone of silence, or is it open and the IP address is used by other equipment in your production area? Because a bad actor can come in on that same IP address and affect different equipments within your business. So I think you really need to look at it from a risk assessment perspective to try and work out which ones are going to be where you're going to put your focus. Okay, brilliant. Question from Hoa, even longer question. Regarding standards, have GFSI benchmarks or FDA regs officially mandated cybersecurity as a core component of food defence yet? Or is it still just a recommendation? Regarding risk, in terms of risk assessment, the likelihood of cyber manipulation going undetected seems quite low in a well-monitored facility. Is there evidence to prove this is actually a high probability threat?
Regarding quality versus safety, while recipe changes usually fall under quality, food defence is primarily about food safety. How do we justify including these quality-related parameters in a food defence plan? Wow.
That's a lot of questions in that. So let me go the first bit about, is it mandated in GFSI? It doesn't need to be specifically mandated. We talk about food defence, and cyber comes into food defence. And as, who was it before, was put a couple of links into some incidences. We had the big JBS incident in the US. That was massive. That was extortion. They paid the money because they basically stopped their whole production. So, you know, you think about, even if you're having to move stock from A to B, if you have to log it in one system and log it out of another system, if you can't move that stock, you don't go anywhere. Your business stops. So even from a business perspective, you should be doing this stuff. Okay? So it doesn't have to explicitly be written into GFSI. It still comes under food defence, because we know that bad actors can do this stuff and they can affect food safety attributes. So think about if somebody logged in and changed your pasteuriser, they put the temperature down to, 50 degrees Celsius. We're supposed to be up above 92 or whatever. You think it's above 92, you're a milk factory, you've now just sending out milk that hasn't been pasteurised. Then how many people get sick? You know, so these are very, very real things that can happen. So again, you've got to decide in your own business based on what controls you've actually got in place. And look, if you believe it's you've got a well-monitored facility, well, that's fantastic. You know, not everybody's got that, unfortunately. Quality v safety, again, you're going to have to do that based on risk assessment. And recipe changes can happen. It's not just about quality. What about if part of your recipe was to have a preservative added? So you put a preservative in your recipe and then all of a sudden it's not going in at the level it's supposed to be in at. Yeah, think about it in that context. Next question, Simon.
I thought there was a third part to that. No, right. Okay. Mariella, the technological defence of food only applies to companies that are fully digitalised. That's true?
Not fully. Again, you could just, even if you're doing record keeping on tablets on the production floor, you got to think about how that affects your data. You're making decisions to release a product on data, and if you're looking at data and it looks A-OK, and you release that product but it's not A-OK, that can become an issue. Does that make sense?
It does, yeah, to me. A question from Moni. How can we ensure the integrity of service providers who grant access, such as access card issuers?
So that's obviously going to be through your approved supplier program, and you're going to have your requirements in place for that and your metrics, and, you know, you got to make good decisions around that and be asking probably more questions on what people are.
Yeah. And Emma asking, as you can receive food safety alerts via email, what threat alerts and intelligence are provided to stay informed about potential cyber threats?
Emma, I'm just trying to think of what perspective are you talking about there? Because yes, you get food safety alerts, and a lot of these systems will send an alert to somebody to their email. Okay, here's an example. You have an alert sent to an email set up with the QA manager. You go through and, again, what I was saying about go back and review your systems, like how many people are getting that alert? if that person's off on leave for 3 days, nobody gets the alert. Business as usual. The little worker ants just continue on working. So that would be one of the things that I would expect you'd have dual thing around. It just doesn't go to one person. You'd be surprised how many people just have it go to the QA manager for those alerts.
Yeah. Makes sense.
I don't know. I don't feel like I answered your question though, Emma.
I don't know if they mean, is there anything external, like any...
To find out how you keep up to date with cyber threats.
Things like that. That might be. I don't know.
Yeah, look, there are actually. So I subscribe to a certain newsletter that will give me general stuff that's happening with a lot of the big software companies around the world, and how they've been exposed. Who's been hacked. It's actually it's frightening to read it, actually. You'd be surprised how many times Microsoft's getting hacked if you're all on Office and Teams and all of that type of stuff. So, look, Emma, let me find it. If you want to just send me an email to amanda@hazardmentor.com, I will send you the link.
Sounds good. Brilliant. I think that's it.
That's it.
Felix has just said excellent answers. So
thanks, Felix.
It's like 2 minutes to 1 a.m.
Right, I'm done.
Brilliant. Yeah, so thanks very much. I think you're back in November, so we'll see what time we do then. But thanks for staying up, and it was great sharing your knowledge and expertise with everybody. And have a good night's rest.
Thank you. And if you're got any other questions, I know Simon puts these on the website. So under where the video goes, there's always the comment section. Yeah, is that right, Simon?
Yes, correct.
So, yeah, you can put your questions there, and I'll log in and answer.
Brilliant.
So thank you very much, everybody. Enjoy your weekend. Friday night's pretty awesome. Nothing major goes down because my Friday night's done. Everyone else hasn't got there yet.
Thanks very much again, Amanda. And thanks everybody for turning up. Have a lovely weekend, everybody. See you on the next one. Cheers.
Thank you.